Good morning, everybody, and welcome back to Next Door NetAdmin. And today we're going to talk about redundancy protocols. And today we're going to talk about redundancy protocols. Specifically, I'd like to talk about something that's called first hop redundancy protocols. What is this? What even is this concept before we start getting into the details? Okay. So if you have a network and you want it to be available redundantly, you want it to be available in case equipment fails or networks go kablooey or what have you, you're going to need some additional equipment. It's all right to have two internet connections, that's fine, but what happens if the router itself goes down? You're going to need a second router. And if you're on a critical network that can't tolerate an outage of hours or however long it's going to take you to drive to the site, troubleshoot it, and replace it, then you need that hardware to be essentially in operation all the time so that it can step in and take over immediately. But how do you do that properly? I mean, it's easy enough to put two devices on the same network segment, easy as cake. You have to make sure that they have a separate IP address, because otherwise, there's going to be a little bit of a conflict. And how do you tell your client devices which one of those they're supposed to use? DHCP will tell them a gateway IP, cool. But then if that one fails, how are they going to figure out that there's a second router that they should be using? Yes, to note the fact, we are talking classical IPv4 here. IP version 6 has router advertisements and other functionality that makes that part a little more reasonable. But in IPv4, how are you going to figure out that there's another router out there? It's not advertising, and you haven't been pointed to it. And so you're going to have some delay while the configuration in the network essentially has to be altered in order to take account of there's other equipment over here that's still working, go use it. So, in an effort to just take care of this entire problem, you have a first hop redundancy protocol, something where multiple routers or first hop devices, it doesn't have to be routers, but it's going to be anything that's acting on layer 3 and doing routing because of that. You want something that is available for the devices to talk to each other to confirm whether they're up or down. And you want something that is going to be transparent or mostly transparent to the end stations so that they can just keep communicating and they don't need to worry about which device they're going to because that's not their concern. I personally have used 3 different first hop redundancy protocols. And those are the ones that I'm going to focus on discussing. The 3 that I have used are the hot standby redundancy protocol, the virtual router redundancy protocol, and the Common Address Routing Protocol. I could be wrong on that, don't quote me. HSRP, VRRP, and CARP. Cool. What's different about these? Why would we use one over the other? HSRP essentially came first, as far as we can tell, and that is a Cisco proprietary protocol. HSRP version 1 worked on IPv4 only. You had support for 256 different HSRP groups. And it was actually described textually in an RFC. Cool. But it is Cisco proprietary and Cisco patented. Then you have VRRP, which is an actual IETF standard, because they looked and said this is actually something that's useful. Both Cisco and IBM said, hi, we have patents on that. And IETF went, okay, well, it's not actually the same thing, so yeah, we're going to go ahead with it anyway. And Cisco eventually, I don't know about IBM, but Cisco eventually said, okay, fine, we do have a patent on this stuff, but we're not going to use it offensively. We're only going to use it if somebody tries to sue us. And then we'll say, well, hey, we have this patent, so go away. And then you have CARP, which was designed by OpenBSD, the OpenBSD developers, because previously to Cisco saying, well, tell you what, we'll only use our patent defensively. Before that, Cisco's position of, well, we think that anybody implementing VRRP is going to have to license our patent, and that's our position on it, so mind yourself. OpenBSD went, okay, well, we don't like that. And it kind of goes against the whole spirit of open source, where it's open. You can develop it as you please. You can fork it as you please. You can, here's the code, run it, modify it, view it, whatever. It's not encumbered. So OpenBSD went and developed CARP. One little glitch with that. They actually did take that to IETF, to IANA, and said, hey, we would like to have an actual protocol number assigned to this so that it's official. And unfortunately, the official response was, well, it hasn't come up through any standards bodies. There's been no collaboration on this. And there's no textual actual implementation spec that describes how hosts should do this and how it should not. This is just a pile of code. So we're not going to give it an official protocol number. And OpenBSD went, oh, okay then. Well, guess we're going to use the same virtual MAC address and the same protocol number as VRRP. So there you go. Now they're now officially incompatible. That was a choice. Insofar as it was a choice, it probably wasn't as unreasonable as it sounds. If you're running BSD devices, you would assumably use what's there. And if you're using BSD devices, do you need them to interoperate with other devices that are made by other manufacturers? Your mileage may vary. HSRP version 2 does support both IPv4 and IPv6. Again, this is the Cisco proprietary one. It also increased the number of group IDs from 256 to 4096. Cool, fine. But it's not actually documented in any sort of a spec. So it is 100% Cisco proprietary. There is no description of how it works. Good luck. So of the three that I have used, one is very much Cisco proprietary, only Cisco to Cisco. One is officially multi-vendor, and multi-device. And I have used that to, try and set up redundancy between a Cisco device and in this case, a FortiGate, a Fortinet device. And then you have one that is very much started with OpenBSD, was later ported to FreeBSD. There is a port for Linux, but it's not going to be compatible with VRRP, and it actually collides with VRRP under the right or wrong circumstances. So it just depends on what devices you're using and who you need them to talk to. So how do these work? Well, you probably heard me just a couple minutes ago use the word virtual MAC. In order to make these work, yes, obviously each device has its own MAC address, each device has its own IP address, but it also has a virtual MAC address that is shared among the devices, so that if one device goes down, the virtual MAC address can be taken over by another device, and other devices on the network, client devices, can just keep sending traffic to the virtual MAC address for their virtual gateway, and it doesn't matter which actual router it's going through at the time. Cool. It's transparent to all your clients, and it just works. It just gets taken over. Now, there are some things that will drop unavoidably. If you have a stream going through and it switches to another device, you probably don't have the same firewall state. In the BSD world, you can. They actually have a tool called pfSync, which synchronizes the packet filter between multiple devices acting as routers. So this is something that was designed in there to actually synchronize firewall states so that you don't drop any streams. The devices were up to date at the time that one of them fell offline. But there's a high risk, if you're not using something like pfSync, that your firewall states may not be synchronized. There are other first hop redundancy protocols out there, I might add. I know that Extreme Networks has one. I know that Juniper has one. I know that Mellanox has one. I know that Cisco came out with an updated protocol, the Gateway Load Balancing Protocol, which does do your failover, does do redundancy, but it's also designed where multiple devices can be active and forwarding packets at the same time for the same network segment. I've never touched it. I don't know anything about it. I just know it's there. So I can't tell you too much about it, other than the fact that it's there. All of these, virtual MAC addresses are going to be dependent on a group ID. Now, some protocols will call it a group ID, some will call it a virtual host ID, but in concept, I'm just going to use the umbrella term of group. If you have a group ID, that group ID will essentially show up in the MAC address so that you can have multiple groups for these devices, and those groups will be able to use a different virtual MAC address. Because of this, yes, VRRP and CARP use the same protocol number, and they use the same range of virtual MAC addresses. But it turns out you can actually run both on the same network segment as long as they have different group IDs. Because as long as VRRP is using A and CARP is using B, cool, they're not going to collide and butt heads with each other. If they're both trying to use A, then there's a problem. Fine. Some of these protocols have authentication built in, which is strongly recommended. so that you don't have rogue devices going in and saying, oh, actually, I'm part of this group and I have the highest priority, so everybody send your traffic to me. That's not great for security. So having some security in there is a good thing. And this is, in fact, one of the things that CARP implemented specifically to make themselves different from HSRP and VRRP. They implemented a much stronger degree of cryptography than the other protocols had at the time. What else can I tell you about these? These also have priorities. These protocols have priorities. And this is how the devices determine which one should be active at any given point in time. By default, at least in HSRP, every device has a priority of 100. And so your election of who's going to be active and who's going to be standby is based on other factors that may not be what the admin wants. So it is strongly recommended that you set your own priorities so that you can say this device should be the higher priority. It's got a priority of 110. And then this device has a priority of 100 or 90, and it should be the secondary or the tertiary device, depending on how many devices you want to have available for redundancy. And that works. If a device loses its internet connection, it's designed to drop its priority level in HSRP anyway, if it's actually using a tracked connection. Then it'll drop its priority by 30 or some configured amount in order to indicate, hey, I should have a lower priority now because my tracked connection is not working. Okay. And then at that point, the next highest priority will take over if you've configured it to do so. There's a command called preempt, which means, hey, if the other device is still there, but you have a higher priority now, just take over. Just forcibly take over. Cool. All right. It has the possibility to cause some of those disruptions I mentioned if you're not synchronizing firewall states, but better than using a suboptimal connection forever, and better than better than just black holing traffic because you have nowhere to send it. Cool. VRRP works much the same. I've worked with that a lot less. The one time I was really, really actively using it was when I was trying to make a Cisco device talk to a FortiGate, and it would work sometimes. I don't know why, but sometimes these devices had multiple VLANs. And the way you set this up, obviously, if you want a gateway on VLAN 6, you're going to have to communicate over VLAN 6. If you also want redundancy for the gateway on VLAN 5, you're going to have to set it up again on VLAN 5 because it's got a different gateway IP address, it's got a different virtual MAC address, and different group. Fine. I could see that the Cisco was sending and receiving VRRP packets on the VLANs it was supposed to. And the FortiGate could see some of those, but for some reason it didn't see all of those. Same physical cable, same network, but some VLANs it would receive and some it wouldn't. And on the VLANs where it wouldn't receive, obviously the FortiGate goes, oh, well, I can't hear the Cisco device anymore, la 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 la, so I'm going to take over. And suddenly you'd have two routers that are both trying to service the same virtual MAC address and the same IP, and everything goes to a very unhappy place. So that I did never get that working fully, and I never really figured out why, which is too bad. I haven't had the opportunity or the reason to revisit that since. And without knowing what the problem was, I have no idea if I would run into the same issues. CARP I've used mostly in BSD systems, mostly in NAS, actually, with the true NAS, because when you have a high availability, true NAS, the nodes are communicating with each other using CARP, particularly when they're based on BSD. I don't know what the Linux ones do. I haven't worked with a high availability unit that's been running true NAS scale, so But in the enterprise, the BSD based one, CARP is definitely in use. So you can have a virtual controller address, and then the two individual controllers have their own IPs. They're not doing routing per se, but they are doing redundancy so that you can use a single IP address to direct all your clients to, and it'll go to whichever controller happens to be active at the time, depending on what failovers or reboots have had to happen. So while this was designed specifically for routing, you can see that this is something that is useful in situations other than routing as well. It's essentially useful anywhere you have a device that needs to be redundant, that needs to be available transparently to a bunch of clients, and they don't need to know the details of how this actually works. There's probably quite a few quirks to the implementation. I can easily show you a demonstration of HSRP. The other two, not so much. I realize that HSRP is Cisco proprietary and all that, but it happens to be the equipment I have the most of kicking around because I came up through Cisco networking, so I've got lots of equipment hanging around. So I might demonstrate HSRP to you just to kind of get an idea of the principles of operation and what kinds of things you would be looking for or looking to implement. So we'll see. Hopefully that was of interest to you, useful for your networking endeavors. If you have questions, comments, thoughts on other things that I could talk about, feel free to let me know down in the comments section. Always love to, hear comments on what let's see. I don't love hearing that people are having difficulty with things. In fairness, that's kind of not the point. But if you're having issues with something, and if I happen to think that I have an idea as to what might happen, I never mind helping out. Sometimes it's difficult for me to actually understand what's going on because I'm not sitting in front of the same machines that you are. But if I can help, I'm okay with, offering what advice I can. So in that sense, I like to hear comments. And if it works for you or if it's brightened your day, I love hearing that too, because it makes me feel good to know that I was actually able to help somebody and not just sit here being a talking head, which I do on a weekly basis. So yeah, again, hopefully that was of interest and useful to you. Otherwise, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.